This is your lecture for chapter 6, section 2. You're still solving this system, but in this section, we're going to see how to know if there's no solution or infinite solutions. So first, write your matrix. 1, negative 1, negative 2, 2, 2, negative 3, 6, 5, and 3, negative 4, 4, 12. So we solve these just like we did in section 1. Now in this one, it's kind of nice. They already gave us a 1 up at the top. So I want to make these numbers below it a 0. So negative 2 times row 1 added to row 2, and negative 3 times row 1 added to row 3. But row 1, I'm not changing. So negative 2 times 1 added to 2 is 0. Negative 2 times negative 1 is 2, plus negative 3 is negative 1. Negative 2 times negative 2 is 4, plus 6 is 10. Negative 2 times 2 is negative 4, plus 5 is 1. Bottom row. Negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times negative 1 is 3, plus negative 4 is negative 1. Negative 3 times negative 2 is 6, plus 4 is 10. And negative 3 times 2 is negative 6, plus 12 is 6. Let me double check my numbers because it's real easy to make mistakes in here. All right, now I want to make my second column, the middle number, a 1. So I'm going to do negative 1 times row 2. So row 1 stays the same. Row 2 changes signs. Now I need my 0 underneath right here, so I can get that by adding row 2 and row 3. So 1, negative 1, negative 2, 2, 0, 1, negative 10, negative 1. So 0 plus 0, 1 plus negative 1, negative 10 plus 10, and negative 1 plus 6. So let's transpose that over here. Let's line those up a little better. And I don't remember my middle numbers. 1, negative 10, negative 1. Okay, so my next step in theory would be to make this a 1. But I can't do that because it's a 0. If I add 1 to everything, it changes my zeros over here that I need to leave. So if I look at my equation here on the bottom, I have, remember this is my x, my y, and my z, so I have 0 equals 5. That's not true, so this equation has no solution.